Hello, welcome to Code for Teachers. I'm Michael Taggart, and this is episode 4, Build a Number Guesser. So what we're going to do is we're going to take the skills that we've learned in the first 3 episodes, using integers, using input, printing out, using conditional statements, putting all of this together to create a simple lesson for our students where they're going to build a program that asks a player in a game to guess a number. Now, we can modify this kind of activity for many different levels. We're going to start with 1, which I would target 4th, 5th grade maybe, in terms of order of operations, math sense, and general ability to, developmentally, to write code easily without too many typos. That's a keyboarding thing. If you try to introduce typed programming to students younger than that, it tends to be a little bit difficult just because they're not as familiar with the keyboard yet. But if you have students who are excellent with their number sense and their order of operations and can type well, use your judgment as to what is developmentally appropriate for your students. So the version of the number guesser that we're going to use, the lesson design of it, is going to get students to collaborate. Everybody's going to write code, but once the code is written, different students will actually use each other's programs and kind of challenge each other with the mathematical expression that they'll be trying to guess. What's really important for a sense of ownership and also for a sense of differentiation is the idea of remix. So we're going to give you a template of code here, but it's actually encouraged for both you and students to play with it, modify it, extend it, because we're already hitting the learning objectives that we need. So going beyond is just all bonus. So let's talk about program design first. We have to think about it in this way before we start writing some code. So we're going to start with a number to guess, and different versions of a number guesser program might use a random number generator to create your number, which is fine, might be interesting, but this one is more about talking about order of operations. So we're going to define the number using mathematical operations. So something like assigning the variable number to 7 times 2 minus 8 plus 5. And so you have to do some thinking about what that means in terms of order of operations. And it's going to ask the player to guess, and then it's going to tell the player if the guess was too high, too low, or right on the money. And you can see even in that description the word if, so we know that there's going to be a conditional statement in there somewhere. All right, so before we get onto the lesson design, let's take a look at the actual code. All right, so I haven't written the code yet. I thought we'd write it together, but I do have the title multi-line comment with those triple quotes. All right, so the first thing we're going to do is create the number. Let's use the expression from the slide. So that was 7 times 2 minus 8 plus 5. Right, so obviously we're obeying operations here where 7 times 2 multiplication happens first, and then subtraction and addition have equal weight. So we're going to proceed in order. So 7 times 2 is 14, minus 8 is 6, and then plus 5 is 11. If we were to put parentheses around 8 plus 5, right, much different result. So Python is sensitive to parentheses, exponentiation, things like that. So this is a great way to start teaching order of operations. So let's do this. So we'll do number equals 7 times 2 minus 8 plus 5. And Python will interpret that and give us the resulting value in the number variable. Okay, now we're going to need a guess, and we're going to need to store that guess, just like we did before with the even odd checker. So we're going to say guess equals, and do you remember how we get input from the user? That's right, it's input. So we're going to do input, what's your guess? Eagle-eyed viewers might notice that again we have the problem we had in the even-odd checker where we need to convert that input result into an integer in order for this to work. So let's go ahead and pregame that right now, wrapping this input function in an integer conversion so that we actually have a number, not strings, that we're going to be comparing to number. All right, so we have the number and we have our guess. All that's left is to compare them and tell the user what the result is. So we have three possibilities, right? The three possibilities would be that the guess equals the number. That's one possibility. The other possibilities are that the guess is greater than the number. And then the third possibility is, of course, that the guess is less than the number. All right, so let's begin with that first option, that the guess is in fact equal to the number, that we got the right guess. We'll say if guess, and we'll use that same comparison, guess equals number. Print. You got it. And by the way, just from a teaching standpoint, most of the fun at this level is going to be from students coming up with custom messages in the print statements. So just be prepared for that. Also be prepared for the numbers to get cartoonishly large. I would recommend encouraging students to keep the numbers under 10 million if you want your programs to run in reasonable time. Okay, so we have if guess equals number. Now we're going to have to extend the conditional statement a little bit more than we had in the even odd. In the even odd we had an if and we had an else. But because we have three possibilities here, we actually need to add another section, which is elif. So that's else if. So elif guess is greater than number. So elif in fact takes a test the same way that if does. So we read the conditional statement from top to bottom, just like the rest of code. So if guess is in fact greater than number, then the first test here will fail, and then we have another test that we want it to check before we get to the else. So elif guess is greater than number. I'm going to say print, sorry, that's too high. And you can chain as many elifs down the row as you need to if you have multiple possible conditions that you want to check for. But we only have three in this case. Now, because we only have three in this case, we don't actually have to write another elif, because we've taken care of the first two possibilities. The only remaining possibility, we will use an else to define that. So that's print, sorry, that's too low. Okay. Let me just get rid of these comments here. Okay, let's run this and see what happens. So I kind of pregame it. I know that it's 11 in this case. So let's try a correct answer. All right, let's try a high answer. Okay, and let's try a low answer. Okay, so everything's working here. You could even do some interesting things here with the fail messages. You could do something like actually say the difference, right? So you could say something like, sorry, that's, and then do some string concatenation, right? Plus, so it would be guess minus number plus too high. Now, think data types. We've got a string here with sorry that's. We've got a string here with too high. But here we have an integer. So if we want to print it out concatenated with the other two strings, we actually have to convert it back to a string. And we do that basically the same way we did converting the integer, just like that. So just to see if that works. Right, so if I guess 99, it says, sorry, that's 88 too high. So that kind of gives it away. But it is kind of fun to see that you can in fact do that. So let's talk about lesson design. The code is actually fairly simple, but the instruction is where the rubber meets the road. So I would have students work in pairs to write the code, and the reason being that programming can often be a very frustrating exercise, but if they're working in pairs, they can kind of build on each other's successes and mitigate each other's failures. You want to make sure that one person isn't copying directly from another, but even so, again, the goal is not to, at this point, get them to be able to produce code from thin air, but to have fun programming and to get to a place where it works, to get them to that sense of reward where the output is successful. And that, just in my experience, happens faster when they're working in pairs. We do want to make sure that everyone's code has the correct output to continue. This is an opportunity to talk about attention to detail. So you want to make sure that there are spaces where there need to be spaces, that there are colons where there need to be colons. There may be some areas where things can be different. Certainly the print messages, as long as they're meaningful, they can be different. But as long as the correct output is occurring, then everyone can move on. So you want to have the partners create new math expressions, different math expressions, for their secret number, and then have the partners switch and try to attempt to solve each other's secret number based on that math expression. So they're running each other's programs, that's going to be fun, but they're also using their understanding of order of operations to derive what that secret number is. Then after the partners do that, you can open it up to the entire class and have them walk around and try to test each other's expressions. What will definitely happen, and I encourage this, is that over time they might want to modify their expressions to make them more and more complex. Definitely do that so that you really are playing with this idea of order of operations. Okay, so that's pretty much it for the application of this. I'd love to hear back from you if any of you have implemented this in your classroom, or you have other versions of a number guesser that you've used successfully. So this is the end of our first section on Python. In the next section, we'll be talking about loops or iterations and how those can be useful in teaching some different concepts, both in math and otherwise. All right, thank you very much for watching. Again, as always, if you're interested in reading more about education technology and how programming can be useful in the classroom, I encourage you to read theforeverstudent.com. You can follow me or message me on Twitter at mttaggart. You can see code that I've written for Python computer science in the past, and hopefully pretty soon I'll be putting some of this code up on GitHub at github.com/mttaggart. Okay, this is Code for Teachers. Thanks for watching.